can find the value of current in different arms using node analysis method. Let's apply node analysis method to find the currents in the various arms of this network. So in node analysis method, first is we look out the nodes junctions. So this is one node where there are three wires they are meeting. So this is a node, this is a node, this is a node. First step is, let's take a one reference node and we take it arbitrarily at 0 volt. We can take any node at 0 volt. Let's say we take this at 0 volt. So if this we take it as 0 volt, so over here this is a battery. So the positive terminal at 0 volt, the negative terminal is negative with respect to this. So this is at minus 10 volt. So if this is at minus 10 volt, so this is also at minus 10 volt. And rest of these two nodes, let's say we can call it as X and we can call it as Y. And we can say for node X, I1 plus I2 plus I3 is equal to 0. That is, we say I1 plus I2 plus I3 is equal to 0 for the node X. I is equal to V by R. So what we shall be doing is, now if we have to find the value of current through a resistor, we will find what is the potential difference across the resistor, divide by the value of the resistor, and we will find the current. I1 over here. So if this is Y, so this is also at Y, so this is at Y plus 20. We are moving from negative terminal to positive terminal, the potential difference is 20 volts. So if this is Y, so this is going to be at Y plus 20. So if this Y plus 20, current is moving in this direction, so the potential of this is greater than the potential of this. Across the resistor, the potential difference is X minus Y plus 20. This minus this potential is potential difference, divided by the resistance 5 plus I2. This is at 0, this is at minus 10, this is X, this is at minus 10. So potential difference is, if you talk the current I2, X minus minus 10, X minus minus 10 divided by 5, I2 job is done. Now I3 plus I3, this is X, the other end is at 0 volt, so X minus 0 by 10 ohm is going to equal to 0. So this is one equation we get. Now we can also make an equation for the node Y. Over here we can say I4 and this is I5 and this we can take it as I6. So I4 plus I5 plus I6, we say it is equal to 0. So if this is, so what the current is flowing in this wire over here or over here is one and the same thing. Now this is done. We will not consider this. Its job is done. We will not confuse it with this. Now we are taking this at a highest potential and we say I4 plus I5 plus I6 is equal to 0, because this is KCL is applicable for all the nodes. So if this is at Y, so this is at Y plus 20. If this is at Y plus 20, now we are taking the current I4 moving in this direction. So Y plus 20 is greater than X. So Y plus 20 minus, because whatsoever current shall be flowing in this direction, the same current shall be flowing in this direction. So this is at Y, this is Y, this is Y plus 20, this is Y plus 20, and this we have taken at X. So Y plus 20 minus X is the potential difference. Potential difference divided by the resistance is going to give the current. V minus 20 minus X upon 5 is the value of the current I4. What is I5? I5 is Y minus 0, this is at 0, this is at 0, this is at 0, Y minus 0 by 5 is the value of I5. What is I6? I6 is Y minus, what is the potential of this? It is a minus 10 volt. Y minus minus 10 upon 5 is equal to 0, because I4 plus I5 plus I6 is equal to 0. This is other equation. We can solve these two equations to get the value of X and Y. So when we solve these equations for the values of X and Y, X comes out to be 60 by 13 volt, Y comes out to 10 by 13 volt. Then accordingly now it is easy to find the value of current in the various arms of this circuit.